December 1944, outside Aachen, Germany. Hauptmann Friedrich Trenkel crouched in the rubble of what had been a Luftwaffe early warning station, staring at a piece of American equipment that shouldn't exist. Trenkel wasn't just any officer. He was chief of Luftwaffe Signals Intelligence, a physicist who had helped develop Germany's Freya and Würzburg radar systems since 1939. For 5 years, he had tracked Allied electronic warfare capabilities, always confident that German radar technology maintained a critical edge. Now, his hands trembled as they touched the casing of an SCR-584 radar system, captured intact when American forces briefly overran a forward position before falling back. The preliminary report from the recovery team described capabilities that violated everything Trenkel understood about radar physics: automatic tracking, integrated fire control, a claimed operational range of 40 miles for aircraft detection, all in a system that could be set up and operational in under 30 minutes. Trenkel had dismissed the report as exaggeration, perhaps confusion caused by stress. German Würzburg radars required hours of careful calibration by trained operators. The idea that Americans had created something faster, better, and fully automated seemed impossible. Then he powered on the SCR-584 for the first time. What appeared on that cathode ray tube would shatter 5 years of carefully constructed beliefs about German technological supremacy. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Trenkel had been educated at the Technical University of Berlin, studying under some of Germany's finest physicists. When war began in 1939, he was recruited immediately to work on radar development at Telefunken. His specialty was understanding how radar signals propagated, how to optimize detection ranges, how to filter noise from genuine targets. By 1941, he was analyzing captured British radar equipment, always finding German systems superior in precision and range. The Würzburg radar, Germany's primary ground-based system, could detect aircraft at ranges up to 40 kilometers, roughly 25 miles. It required a crew of 4 operators, careful setup on a stable platform, and constant adjustment to track moving targets. The system weighed approximately 1,500 kilograms and needed external generators for power. Trenkel had personally overseen improvements that increased accuracy and reduced setup time from 4 hours to 2. He considered Würzburg the finest ground radar in the world. When the Americans landed at Normandy in June 1944, Luftwaffe intelligence began receiving disturbing reports. American anti-aircraft batteries were achieving hit rates that shouldn't be possible. Shells were exploding near aircraft with uncanny precision, even in darkness and poor weather. German pilots reported that American guns seemed to track them perfectly, firing predictive barrages that caught aircraft exactly where they would be, not where they had been. Trenkel analyzed the reports with growing concern. The described accuracy suggested radar-directed fire control, but that required capabilities beyond what he believed American technology could achieve. Radar could detect aircraft position, certainly, but translating that into firing solutions for anti-aircraft guns required complex calculations: trajectory, altitude, wind speed, aircraft velocity. German systems required operators to perform these calculations manually, then communicate firing data to gun crews. The process took time and introduced errors. American systems appeared to do this automatically and instantly. If the reports were accurate, and Trenkel had learned to trust frontline observers, it meant American radar had integrated fire control computers that German systems lacked. More troubling, it suggested American radar had capabilities Trenkel hadn't anticipated. In September 1944, Trenkel received intelligence from agents in Switzerland. American forces were deploying a new radar system designated SCR-584. The reports described a mobile system with automatic tracking, built-in computing for fire control, and operational ranges exceeding 60 kilometers. Trenkel examined the intelligence carefully and concluded it was partially accurate but exaggerated. 60 kilometers over 37 miles was possible for large, fixed installations. But not for a mobile system. The power requirements alone would be prohibitive. Then came Aachen, As American forces pushed into Germany in October 1944, fighting around the city was brutal and chaotic. German counterattacks briefly recaptured forward positions. In one such action, troops overran an American anti-aircraft battery and, miraculously, found the radar system intact. The Americans had retreated so quickly they couldn't destroy it. Trenkel received word within hours. He immediately arranged transport to the front, bringing 2 senior engineers from Telefunken. When they arrived at the captured position on December 12, 1944, Trenkel felt a moment of vindication. The SCR-584 sat on its mobile trailer, olive drab paint marked with American military designations. It looked compact, far smaller than a Würzburg installation. Perhaps the intelligence reports had been exaggerated after all. Then he began examining the system more closely, and that initial confidence evaporated. The SCR-584 consisted of a radar dish approximately 6 feet in diameter, mounted on a rotating base. The entire system, radar, power supply, control station, was integrated into a single mobile unit that could be towed behind a standard truck. Compare this to the Würzburg, which required multiple vehicles for transport, external generators, and careful site preparation. But size meant nothing without performance. Trenkel needed to see what this machine could actually do. His team spent the next hours connecting captured American generators, checking power systems, ensuring nothing had been damaged in combat. By late afternoon on December 13th, they were ready for initial tests. Trenkel sat at the control station, studying the layout. Everything was labelled in English, but the function of most controls was obvious to someone with his expertise. Power switches, range settings, tracking controls. But there were additional systems he didn't immediately understand. A complex panel labelled Computer, with settings for target speed, altitude, and gun characteristics. An automatic tracking switch. Controls for something called lobe switching that he'd never encountered. He powered on the system. The cathode ray tube glowed to life, far brighter and clearer than the displays in Würzburg radars. The sweep began immediately. A bright line rotating around the screen. And then, within seconds, multiple blips appeared. Aircraft contacts. Trenkel felt his pulse quicken. The sensitivity was remarkable. These were aircraft at significant range, appearing clearly on the display with minimal noise. He called his assistant. Werner. Check the range setting. What are we looking at? Werner examined the controls. Set to maximum range, Herr Hauptmann. That's 64 kilometers, 40 miles. The intelligence reports had been accurate. Trenkel watched the display, counting contacts. 7 distinct aircraft, all at ranges between 50 and 64 kilometers. He knew from Luftwaffe flight schedules that a training group was operating in that area. The SCR-584 was detecting them with crystal clarity at a range that exceeded Würzburg's maximum capability. But detection alone wasn't what made this system revolutionary. Trenkel activated the tracking function. He selected one aircraft blip on the display. Then he engaged the automatic tracking switch. What happened next would haunt him for the rest of his life. The radar dish began moving on its own, smooth, precise movements tracking the selected aircraft automatically. The system was following the target without human input, adjusting continuously as the aircraft maneuvered. On the display, crosshairs remained locked on the target blip with perfect accuracy. Trenkel sat back, feeling cold despite the heated control cabin. This was automatic tracking, real automatic tracking, not the assisted systems German engineers had theorized about, but never successfully implemented. The SCR-584 was doing what required 4 trained operators on a Würzburg and doing it better, faster, with no human intervention required. Werner spoke quietly. Herr Hauptmann, look at the computer panel. Trenkel turned his attention to the fire control computer. As the radar tracked the aircraft, the computer was generating firing solutions automatically. Range to target, altitude, speed, bearing. And, most remarkably, predicted future position. The system was calculating where the aircraft would be when shells reached that altitude, generating firing data that could be fed directly to anti-aircraft guns. He'd seen enough. Trenkel ordered the system powered down and called for a complete technical examination. Over the next 3 days, Trenkel and his team disassembled the SCR-584 section by section, documenting every component, every circuit, every innovation. What they found was a masterclass in engineering sophistication that exceeded German radar technology in virtually every measurable way. The heart of the system was a cavity magnetron, producing microwave radiation at a wavelength of 10 centimeters. Trenkel examined it with something approaching awe. German radar used longer wavelengths. Würzburg operated at 53 centimeters. The American choice of 10 centimeters meant higher resolution, better target discrimination, and the ability to use a smaller antenna dish while maintaining range and accuracy. But producing stable, powerful microwave radiation at 10 centimeters required manufacturing precision that Trenkel knew German industry was struggling to achieve. The magnetron itself was a sophisticated piece of equipment, its resonant cavities machined to tolerances of hundredths of a millimeter. Any variation would shift the operating frequency and degrade performance. More impressive was the modulator, the system that generated precise pulses of high voltage to power the magnetron. The SCR-584's modulator was compact, reliable, and capable of producing thousands of pulses per second with consistent power levels. German modulators were larger, less reliable, and required constant maintenance. The American version showed evidence of mass production techniques that maintained quality while enabling rapid manufacturing. Werner called from the receiver section. "Herr Hauptmann, you need to see this." Trenkel joined him, examining the receiver circuitry. What he saw made his stomach tighten. The receiver used advanced, super-heterodyne design with multiple stages of amplification. Each stage employed vacuum tubes smaller and more sophisticated than anything in German production. The circuit design minimized noise, maximized sensitivity, and included automatic gain control to prevent overload from strong signals. But what truly stunned Trenkel was the lobe switching mechanism. The SCR-584 used a technique he'd read about in theoretical papers but had never seen implemented. The system rapidly switched between two slightly offset radar beams, comparing signal strength to determine exact target direction. This conical scanning technique enabled the automatic tracking the radar could detect minute deviations from perfect aim and correct them continuously. Implementing conical scanning required components that could switch thousands of times per second with perfect reliability. The American system did this effortlessly. German engineers had discussed similar approaches but abandoned them as too difficult to manufacture at production scale. Trenkel examined the fire control computer next. It wasn't a digital computer, those didn't exist yet in any practical form. Instead, it was an analog computer, a mechanical electrical marvel that used rotating cams, electrical potentiometers, and servo motors to solve ballistic equations continuously in real time. The operator would input gun characteristics, muzzle velocity, shell weight, ballistic coefficient. The computer would receive target data from the radar range, bearing, altitude, speed. Then it would calculate the firing solution automatically, accounting for target motion, shell flight time, even basic atmospheric conditions. The output was azimuth and elevation angles for the guns, updated continuously as the target moved. Trenkel had seen German attempts at automated fire control. They were crude by comparison, requiring constant operator adjustment and prone to errors. The SCR-584's computer was elegant, reliable, and remarkably accurate. An experienced gun crew using this system could achieve hit probabilities several times higher than manual aiming. But the true genius was integration. Every component of the SCR-584 worked together seamlessly. The radar detected targets, the tracking system locked on automatically, the computer generated firing solutions. The whole process from detection to firing data took seconds, not minutes. One operator could do what required a team of 4 on German systems, and do it better. On December 16th, Trenkel completed his technical assessment. He sat in a freezing office in Aachen, staring at pages of notes, feeling the weight of what he'd discovered. The SCR-584 represented a radar technology gap of at least 3 years, possibly 5. Every major subsystem showed American advances that German industry couldn't replicate in the near term, he thought, about production. Intelligence suggested the Americans were building SCR-584 systems by the hundreds, possibly thousands. Each one would make American anti-aircraft defenses devastatingly effective. German bombers, what few remained operational, would face defensive fire of unprecedented accuracy. Luftwaffe fighters would be tracked with precision they couldn't evade, but the implications went deeper than tactical considerations. The SCR-584 was evidence of systematic American technological and industrial superiority. The magnetron production required advanced manufacturing. The computer required precision machining and electrical components. The whole system required a supply chain that could deliver sophisticated parts reliably at scale. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Trenkel knew German industry was degrading rapidly. Allied bombing had destroyed factories and disrupted supply chains. Skilled workers were being drafted or killed. Quality control was deteriorating. The gap between what Germany could build and what America was fielding was widening every month, not closing. He began drafting his report, choosing words carefully. The technical analysis would be straightforward: document the SCR-584's capabilities, compare them to German systems, explain the significance, but the strategic implications would be harder to communicate. How could he tell Luftwaffe Command that American radar had leaped ahead by years, that the technological superiority Germany had relied upon was a myth, that the war was being lost in laboratories and factories long before it was lost on battlefields? Trenkel wrote methodically, presenting evidence systematically. He documented the cavity magnetron's advanced design, including photographs and technical drawings. He explained conical scanning and its implications for tracking accuracy. He detailed the fire control computer's capabilities and how it multiplied defensive effectiveness. His conclusion read, "The SCR-584 represents radar technology significantly more advanced than current German systems. American capabilities in microwave generation, automatic tracking, and integrated fire control exceed Luftwaffe systems by an estimated 3 to 5 years of development. This system is being produced in quantity, suggesting American industrial capacity for sophisticated electronics far exceeds previous intelligence estimates. Recommendation: immediate priority to radar technology advancement and assessment of whether current air operations remain viable given enemy defensive capabilities." He knew the report would be controversial, possibly dangerous. Acknowledging enemy superiority could be construed as defeatism, but Trenkel was a scientist. He believed in observable reality. The SCR-584 was real. Its capabilities were documented. Denying the evidence wouldn't change facts. His commanding officer, Oberst Heinrich, read the report with a deepening frown. Trenkel nodded. "The evidence is undeniable. Every subsystem shows advances we cannot currently match. But we've always had superior radar. Our scientists are the best in the world." "We had superior radar in 1940, Trenkel corrected gently. "We may have even maintained parity through 1942, but the Americans have been developing aggressively while our resources went to other priorities. Now they've surpassed us." Heinrich looked uncomfortable. "If I forward this to Berlin, you understand how it will be received? They don't want to hear that Americans are superior in anything." "I understand, but the information must be communicated. We're sending pilots against defenses they cannot defeat. We're losing aircraft to a technological gap our leadership doesn't acknowledge." "Write a shorter summary," Heinrich said finally. "Focus on the technical capabilities. Minimize the comparative assessments. I'll forward it, but I cannot guarantee they'll listen." Trenkel prepared a condensed version, though he kept his core conclusions intact. The report moved up through Luftwaffe signals intelligence channels. At each level, it was read, annotated, and passed higher. Some officers recognized its significance. Others dismissed it as the pessimism of an engineer who'd been impressed by enemy equipment. By the time the report reached Luftwaffe High Command in Berlin in early January 1945, it had been summarized to emphasize captured equipment analysis while downplaying conclusions about German technological inferiority. A staff officer presented it at a briefing, describing the SCR-584's capabilities but framing them as interesting rather than alarming. When questions arose about whether German radar could match these capabilities, the response was confident. Our engineers, examining the system, we will incorporate useful features into future designs. No mention of the 3 to 5 year technology gap, no acknowledgement that future designs would arrive too late to matter, no recognition that the war was being lost in part because of the very technological disparities Trenkel had documented. In February 1945, Trenkel was summoned to Berlin for a technical conference on radar countermeasures. He brought with him detailed documentation on the SCR-584, hoping to present his findings to a broader audience of Luftwaffe technical staff. What he encountered instead was a leadership trapped between reality and ideology, unable to reconcile the evidence before them with the beliefs that sustained the regime. The conference took place in a building that had been partially damaged by bombing, then hastily repaired. Trenkel arrived to find approximately 30 officers, and engineers assembled radar specialists, signals intelligence analysts, even 2 representatives from Telefunken and Siemens, Germany's primary radar manufacturers. General der Nachrichtenaufklärung, Wolfgang Martini, presided over the conference. Martini was Luftwaffe Chief of Signals, a capable officer who understood technical matters better than most generals. Trenkel had hoped that Martini would grasp the significance of the SCR-584 findings. The morning session covered various topics: radar jamming techniques, improvements to Freya early warning systems, proposals for new installations. When Trenkel's turn came, he was allocated 15 minutes to present findings on captured American radar equipment. He began methodically, describing the SCR-584's recovery and his subsequent analysis. He showed photographs of the system, technical drawings of key components, performance data from testing. The audience listened with evident interest as he detailed the cavity magnetron, the conical scanning technique, and the integrated fire control computer. Then he reached his conclusions. The SCR-584 represents a systematic advance in radar technology. In microwave generation, we estimate American capability is 4 years ahead of current German production. In automatic tracking, 5 years. In integrated fire control, we have no equivalent system even in development. He paused, gauging reactions. Some officers were nodding, particularly those with frontline experience, but he saw skepticism on other faces, especially among the senior staff. Furthermore, Trenkel continued, intelligence suggests the Americans are producing these systems in substantial quantities. If even a fraction of intelligence estimates are accurate, we must assume hundreds of SCR-584 units are now operational, with production continuing. A Telefunken engineer, Dr. Hans Hollmann, raised his hand. Hauptmann Trenkel, you've done excellent technical work, but I must question your timeline estimates. 4 to 5 years ahead seems excessive. We've made significant advances ourselves. Trenkel had anticipated this. Dr. Hollmann, I've examined our most advanced systems. The Mannheim radar, for instance, is an excellent design, but it operates at 50 centimeters wavelength. The Americans are using 10 centimeters in production systems. That alone represents years of development in magnetron technology. Hollmann frowned. We've developed experimental magnetrons at shorter wavelengths. Experimental, yes. But production? The SCR-584 shows manufacturing quality that indicates large-scale production with consistent quality control. Can Telefunken produce cavity magnetrons at 10 centimeters in quantity? There was an uncomfortable silence. Finally, Hollmann spoke carefully. Not currently. The manufacturing requirements are substantial. We've faced material shortages, skilled labor problems. Exactly, Trenkel said. The Americans are mass-producing what we can barely prototype. That's the gap I'm describing. General Martini spoke up. Hauptmann Trenkel, No one questions the SCR-584's sophistication, but you're suggesting American radar technology broadly exceeds our own. This seems inconsistent with our understanding of German technological leadership. Trenkel chose his words carefully. Herr General, I can only report what the evidence shows. The SCR-584 is not an experimental prototype. It's a production system, built to standards we cannot currently match, deployed in quantities that suggest industrial capacity far beyond our intelligence estimates. Another officer, Oberst Werner, spoke with evident irritation. This sounds defeatist. You're claiming Americans are superior engineers. I'm claiming Americans have superior manufacturing capacity for electronics, Trenkel corrected. Individual German engineers are highly skilled. But engineering skill cannot overcome industrial constraints. If the enemy can produce 1,000 radar sets while we produce 100, the mathematical outcome is predetermined, regardless of individual system quality. Martini held up a hand, stopping further debate. Your technical analysis is noted, Hauptmann Trenkel. We'll take your findings under advisement. Are there specific recommendations? Trenkel had prepared for this. 3 recommendations, Herr General. First, immediate priority to developing shorter wavelength radar. The 10-centimeter band provides substantial advantages we must match. Second, investigation of American manufacturing techniques. We need to understand how they're achieving quality at scale. Third, a realistic assessment of current air operations given enemy defensive capabilities. The third recommendation drew sharp looks. Questioning operational viability was dangerous territory, but Trenkel pressed on. If American anti-aircraft defenses employ SCR-584 systems widely, our aircraft face fire control accuracy that makes current tactics unsustainable. We should consider whether operations should be modified, or if certain, missions should be discontinued. Oberst Werner stood abruptly. You're suggesting we abandon air operations because the enemy has better radar? I'm suggesting we acknowledge reality, Trenkel replied, keeping his voice level. Sending crews against defenses they cannot defeat is not courage, it's a waste. The room erupted in argument. Some officers agreed with Trenkel's assessment. Others accused him of defeatism. Martini finally called for order, ending the session early. As the conference broke up, Martini pulled Trenkel aside. Friedrich, walk with me. They went to a damaged courtyard, now cleared of rubble but open to the winter sky. Martini lit a cigarette, offering one to Trenkel. You made enemies there. I reported facts, Herr General. Facts can be dangerous. Martini exhaled smoke. Tell me honestly, how bad is it? Trenkel considered, then decided full honesty was warranted. The SCR-584 proves the American electronics industry has capabilities we cannot match. Every subsystem requires manufacturing sophistication beyond our current capacity, and they're producing these systems while also building thousands of aircraft, millions of vacuum tubes, and countless other electronics. Can we close the gap? Not during this war. Perhaps not for years after, depending on how the industry recovers. The Americans are operating at a scale we cannot approach. Martini smoked in silence for a moment. Your report will be filed. Some technical recommendations may be implemented, but the strategic implications. He trailed off. The leadership cannot accept that we're technologically inferior. It contradicts everything we've been told, everything we've believed. Then the leadership is operating on false premises, Trenkel said quietly. Yes, but you cannot say that publicly. You've already gone as far as safety permits. Martini crushed out his cigarette. Write up your technical findings. I'll ensure they reach the right engineers. But the broader conclusions, keep those to yourself. Understand. Trenkel understood. He was being told to provide technical data while remaining silent about strategic implications. It was a compromise that satisfied no one, but might keep him alive and potentially useful. Over the following weeks, Trenkel continued analyzing captured American equipment. Each item reinforced the same conclusions. A captured AN/APS-15 airborne radar showed Americans had miniaturized radar to fit in fighter aircraft. A Mark IV IFF identification, friend or foe system, demonstrated sophisticated electronics that German systems couldn't match. A proximity fuse from an anti-aircraft shell, similar to the one Dr. Wilhelm Runge had analyzed, showed miniaturization that seemed impossible, yet was being mass-produced. Every piece of equipment told the same story. American electronics technology had surpassed German capabilities systematically across all categories. The gap wasn't in one area where Germany might catch up. It was comprehensive, affecting everything from basic components to complex systems. Trenkel began compiling a comprehensive comparison of German and American radar systems. The exercise was methodical and devastating. He created a table with categories: detection range, tracking accuracy, setup time, crew requirements, reliability, production numbers. In every category except crew skill, American systems showed advantages. The Würzburg radar, Germany's primary ground-based system, range 40 kilometers, setup time 2 hours, crew of 4, complex maintenance requirements, estimated production, approximately 4,000 units total throughout the war. The SCR-584, range 64 kilometers, setup time 30 minutes, crew of 1 to 2, simplified maintenance, automatic tracking, estimated production, over 5,000 units by war's end. But numbers alone didn't capture the full picture. The SCR-584's automatic tracking meant one American radar could perform the work of multiple German systems. The integrated fire control meant immediate tactical application without additional calculation steps. The reliability meant higher operational availability. When Trenkel factored in effectiveness multipliers, the disparity grew worse. One SCR-584 might be worth 3 or 4 Würzburg radars in terms of actual combat capability. If the Americans had produced 5,000 SCR-584 units, they effectively fielded radar capability equivalent to 15 to 20,000 German systems. Germany had produced approximately 4,000 Würzburg radars total. He showed the analysis to a colleague, Major Otto Hachenberg, who worked in radar development. Hachenberg studied the comparison in silence, then looked up with haunted eyes. "This is what we suspected, but couldn't prove. The gap is worse than we feared." "Much worse," Trenkel confirmed. "And it's widening. American radar technology continues advancing. Ours stagnates due to resource constraints. Can we do anything? Individually? Even if we designed superior systems tomorrow, we lack the manufacturing capacity to produce them at scale." Hachenberg set down the documents. "Then we've already lost." "We lost years ago," Trenkel said quietly. "We just didn't know it yet." In March 1945, Trenkel received new intelligence about American radar deployments in the Pacific Theater. The reports described ship-based radar systems that could detect aircraft at ranges exceeding 100 miles, guide fighter interceptions with precision, and coordinate fleet air defense across dozens of ships simultaneously. He examined the intelligence carefully. If accurate, it suggested American naval radar was even more advanced than ground-based systems. The technical requirements for ship-based radar were severe. Systems had to operate reliably despite ship motion, salt spray, battle damage. Yet Americans appeared to have solved these problems and deployed the technology widely. Trenkel thought about German naval radar. The SeaTact system could detect surface ships at moderate ranges, but struggled with aircraft detection. German ships had been sunk repeatedly because their radar couldn't track incoming aircraft effectively. The Americans apparently had radar that could not only detect aircraft at extreme range, but also coordinate defensive fire from multiple ships. The technological gap wasn't limited to land-based systems. It extended to naval applications, airborne radar, even the miniature proximity fuses. Across every domain of radar technology, the Americans showed systematic superiority. In April 1945, as the Reich collapsed around him, Trenkel wrote a final assessment. It wasn't an official report, there was no longer anyone to send it to. It was simply his attempt to document what he'd learned. perhaps for future historians who might try to understand how Germany had lost so completely. He wrote, "The examination of captured American radar equipment, particularly the SCR-584 system, revealed a technological gap of 3 to 5 years across all major subsystems. More significantly, it revealed systematic American superiority in electronics manufacturing that Germany could not overcome regardless of engineering skill. This gap was not created during the war. It existed before 1939, when the American electronics industry already exceeded German capacity. War mobilization amplified the disparity, as American factories converted automobile and consumer goods production to military electronics at a scale Germany never approached. The strategic implications were profound. Modern warfare increasingly depended on electronics radar for detection and fire control, radio for communications, electronic countermeasures for jamming enemy systems. In all these areas, American technology provided advantages that German forces could not overcome through tactics or courage. The tragedy is that accurate intelligence existed. German engineers examined American equipment, reached correct conclusions, and reported findings to leadership. In every case, the reports were dismissed, minimized, or ignored. The regime's ideological commitment to German racial and technological superiority prevented acceptance of evidence that contradicted core beliefs. Future military leaders must learn this lesson. Ideological conviction cannot overcome industrial reality. The side with superior technology and manufacturing capacity will prevail if that advantage is comprehensive and sustained. Wars between industrialized nations are won in factories and laboratories, long before they are decided on battlefields. On April 30th, 1945, Hitler committed suicide. On May 2nd, Berlin fell to Soviet forces. Trenkel managed to evacuate west, surrendering to American forces rather than face Soviet capture. He was held for interrogation by American technical intelligence officers who were very interested in what he knew about German radar. The interrogation took place in a comfortable room, nothing like Gestapo methods. The American officer, a Major Roberts, was cordial and well-informed. "Captain Trenkel, we've read your report on the SCR-584. Your technical analysis was remarkably accurate." "I tried to be objective," Trenkel replied in careful English. "You concluded German radar was 3 to 5 years behind American systems. Based on what we know now, that estimate was conservative. In some areas, the gap was larger." Trenkel nodded. "I suspected as much. The SCR-584 was the only American system I examined in detail. Other equipment suggested similar disparities." Roberts pulled out a file. "Your report was marked, 'Filed no action required by the Luftwaffe command.' Did that surprise you?" "No. It confirmed what I already knew. The leadership couldn't accept information that contradicted their worldview. To ignore reality, then acknowledge ideological failures." Did other German engineers reach similar conclusions? Many did. Anyone who examined American equipment objectively saw the technological gap. But expressing those conclusions publicly was dangerous. Defeatism charges could be fatal. Roberts leaned forward. "Let me ask you something. When did you personally conclude that Germany would lose the war?" Trenkel thought carefully. "I suspected from 1942 that Germany couldn't win a long war against American industrial capacity, but I knew with certainty in December 1944 when I tested the SCR-584. That system proved American electronics technology had achieved systematic superiority. At that point, German defeat was mathematically inevitable. Because of radar? The SCR-584 required advanced manufacturing in multiple areas: microwave generation, precision machining, electronics production, quality control at scale. If Americans could build that system in quantity, they could outproduce Germany in every category of military equipment. The radar was simply evidence of broader industrial dominance. Roberts made notes. "We'd like you to examine some other equipment, provide technical assessments. Would you be willing?" "Of course. I'm a scientist. Understanding how things work is what I do." Over the following months, Trenkel examined American electronics systems in detail. He saw the proximity fuse that had devastated German ground forces. He examined American airborne radar that had made night bombing precise. He studied American sonar systems, radio equipment, electronic countermeasures gear. Each examination reinforced the same conclusion. American electronics technology had surpassed German capabilities comprehensively. But more impressive than any individual system was the scale of production. The Americans hadn't just developed sophisticated electronics, they'd manufactured them in quantities that staggered the imagination. Over 22 million proximity fuses alone, more than 100,000 radar systems of various types, millions upon millions of vacuum tubes, resistors, capacitors, all the components that made modern electronics possible. In a 1946 interview with American Technical Intelligence, Trenkel reflected on the experience. The SCR-584 was my introduction to a truth I'd avoided confronting. German technological superiority was mythology, not reality. We had skilled engineers, yes. We'd made important innovations, certainly. But innovation means nothing without industrial capacity to implement it. The Americans took existing radar principles many developed in Britain and created manufacturing systems to build radar at scale while maintaining quality. That's not just engineering, that's industrial sophistication of the highest order. Germany never achieved it, even before the war damaged our industry. He was asked whether Germany could have closed the technological gap. Not by 1944, no. Perhaps if we'd recognized the problem in 1939 or 1940 and made massive investments in electronics manufacturing, but we were committed to other priorities: tanks, aircraft, submarines. Electronics got insufficient resources until too late. Even then, I doubt we could have matched American production. The United States had advantages we couldn't replicate. Natural resources, intact industry, skilled workforce, scientific infrastructure. Most critically, they had a consumer electronics industry that could be converted to military production. Germany tried to build military electronics industry from scratch during wartime. The outcome was predetermined. In 1950, Trenkel was recruited to work with the U.S. Army Signal Corps, helping analyze Soviet radar capabilities. The experience gave him perspective on his wartime work. American radar technology had continued, advancing rapidly after 1945. New systems used technologies that would have seemed like science fiction. In 1944, transistors instead of vacuum tubes, digital computers for signal processing, synthetic aperture techniques for ultra-high resolution. German radar development had stopped in May 1945 and wouldn't resume meaningfully for years. The gap that had been 3 to 5 years in 1944 had become a decade or more by 1950. Germany's defeat hadn't just ended the war. It ended German participation in cutting-edge radar development for a generation. Working alongside American engineers, Trenkel saw the organizational and institutional advantages that had produced the SCR-584. The close cooperation between military requirements and industry, the willingness to fund high-risk research, the systematic approach to testing and refinement, the culture that valued practical results over theoretical purity. He shared these observations in a 1953 paper published in a German engineering journal. The paper compared German and American approaches to radar development, using the SCR-584 as a case study. His conclusion was blunt. Individual German engineers may have equaled or exceeded American counterparts in skill. But engineering skill is necessary, not sufficient. Success requires institutions, resources, manufacturing capability, and cultural attitudes that support innovation and implementation. America possessed all of these. Germany did not. The paper generated controversy in Germany, where many still clung to beliefs in German technological superiority. But among engineers and technical professionals, it was recognized as accurate. The war had shattered many illusions. Trenkel's paper was simply making explicit what many had come to understand through bitter experience. In a 1968 interview near the end of his career, Trenkel was asked what lesson future military leaders should draw from his experience. He thought for a long moment before responding. 3 lessons. First, accurate intelligence must be communicated even when it contradicts official narratives. I reported the truth about American radar superiority. That report was filed and forgotten because it was politically inconvenient. The result was continued operations that cost lives to no purpose. Second, ideological commitment cannot overcome technological reality. German leadership believed in racial and cultural superiority so deeply they couldn't accept evidence of American technological advantages. That willful blindness guaranteed defeat. Third, in modern warfare between industrialized nations, manufacturing capacity is as important as battlefield tactics. The SCR-584 wasn't just a good radar, it was proof of American industrial capability to build sophisticated systems at scale. We couldn't match that capability, so we couldn't win the war. Everything else, strategy, tactics, fighting spirit, was rendered irrelevant by overwhelming material disadvantage. He added a final thought. The most dangerous thing a nation can do is believe its own propaganda. We proclaimed German technological superiority so often and so loudly that we began believing it. When I presented clear evidence that Americans had surpassed us, the evidence was rejected because it contradicted the mythology. That self-deception cost hundreds of thousands of lives and guaranteed our defeat. Reality doesn't change based on what you choose to believe. The SCR-584 proved that beyond any doubt. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.